Hi, I'm Chinlu.
And I'm Sal, and this is our next make. When we needed a bigger watering can, Chinlu had this great idea of repurposing an old orange juice container.
First, I drilled some holes in the cap and the bottle. It didn't work as I expected. The water just dribbled down the front. So I found this other cap from our recycling bin and kit bashed it together with a bit of hot glue. It's not the most attractive outcome, but it got the job done. The water was coming out in an arc, still a bit slow, but allowed me to aim at the base of the plants.
And I'm sure this will last for years, but when I saw what Chinlu did, I was so inspired to see if I could design and 3D print my own creation.
And here's how it all came together.
Let's start by establishing a few design constraints. The first is that the spout has to fit this juice container. It's the same exact one that Chinlu is already using. The second is that it has to create a watertight seal. And the third is that whatever we design has to fit within the roughly 8 by 8 by 7.5 inch volume of our 3D printer. I think the best way to create a watertight seal is to actually take advantage of this cap. It has a gasket on the underside that already does an amazing job. So instead of trying to recreate all this geometry in CAD, I think we'll just drill a hole in the top and then design our spout to fit on top of it. Let's head into SOLIDWORKS to get started. Anytime you're designing something that will interact with another object, it's important to take a few key dimensions. Most of the detail on the cap can be ignored, but we need to know its height, maximum diameter, and how large of a hole we can drill into it without compromising the water sealing gasket. With these things captured in a simple CAD model, I can start thinking about how I want the water to flow. Now you may be tempted to jump right in and focus on the appearance of your part, but taking a moment to first think about how the part will function will ensure that it both looks good and works the way you need it to. I start with a sketch that divides the opening in the cap into two areas. This larger, smiley shape is where the water will exit the container, and this smaller oval shape is where the air will enter. The space in between will be for a wall that separates the two. Then I create another sketch in the shape of the path that I want the water to travel. Here's where I need to start thinking a bit about the 3D printing process. I want to avoid needing support material inside of the waterway. Since I'm going to print this standing up on my printer, I have to ensure that the shape doesn't have an overhang at an angle greater than, say, 50 degrees. The draft analysis command paints the model red and green to show me areas where I'll need supports. Now I can design around these two shapes. I'm going to start with a basic spout looking shape and simply thicken up the areas around the cap and the water path. This gets us started, but will probably be too weak and break, so I'll add a shark fin inspired rib along the back. I like the look of this, but I'm concerned about the overhang of the fin, so I'll check things out using the 3D print command. Not only can I see how the part fits inside my 3D printer, but I can tell exactly where I'll need supports. The fin should come out fine, but I always like to challenge myself to see if I can design something that eliminates support material. So I'll add an inclined wall underneath the overhang. The design's all done, but before I print out the whole thing, I want to make sure that the cap fits. So I printed out this small prototype. You'll notice that I also added a small wall on the inside here. It'll act as a diverter to make sure that the water doesn't flow out through the air intake. In order to make sure that the cap fits, we need to drill a hole in it. So let's head out to the shop. I'll use this simple jig to locate the center of the cap and then drill a small pilot hole so I know where the center is when I flip the cap over to drill the larger hole. I started using a Forstner bit because I had an 1.1/8" diameter on hand, but it's really not the right bit for cutting through thin plastic. So I ran out and bought an 1.1/8" hole saw. It's a less common size, but it does exist, and it cuts way better for this application. Okay, let's see if the cap fits. This is great. There's a bit of play, which will give us enough room for whatever adhesive we use, and everything seems to line up nicely. Let's print the full spout.
Wow, this looks so much better than what I had before. It looks like a shark fin. Let's glue it up and test it out.
Yeah, I think the only thing we have to be careful about is that it doesn't get glued on sideways. So let's put the cap on, and now we'll know exactly how to align it. We'll get the hot glue ready right now.
I can't believe this took so little time, a few hours today, and you did such an awesome job. I wonder if we could do something, a different shape. We could have a whole collection of this.
Yeah, I think because this is 3D printed, we can do anything. I mean, so long as we keep the path of the water clear, it could be any shape.
Yeah, I mean, like you said, the path of the water, it just reminds me of a fish kind of jumping out of the water. I wonder if it's like a fish
Like the fish in Super Mario Brothers. They jump
Oh
out.
yeah. Oh, Super Mario Brothers. We could probably do a character from Super Mario.
You know, I love the piranha plant. So like, can we make that work, you think?
Yeah, for sure. Like this is the pipe down here, and it's growing out of it.
Oh, so the stem is here, yeah. And then got the leaves kind of coming off in the head. So the water would come out the mouth.
Yes, exactly, with its teeth showing.
All right, let's give that a shot. I think if we jump into X-Shape, we can do this really quickly. X-Shape is a browser-based subdivisional modeler that comes with a SOLIDWORKS for Makers license. To start off, I'll insert the geometry of the cap and water path that I made in SOLIDWORKS and then design around it. Reusing geometry from another model like this is very common and helps you move more quickly through additional designs. I start by modeling the pipe using traditional parametric techniques. Then I start adding sub-D primitives that I can manipulate like clay. I push, pull, rotate, and scale things until I get the shape I want. I place each major part of the design in its own set. This helps me focus on one piece at a time. I just love how easy it is to work this way. At the end, I just combine everything together and print it. This print is amazing. It reminds me that with 3D printing, you can make almost anything you can imagine. And that's because when you have complicated geometry like this, it'll build support materials. And seeing all of this support material reminds me why I often try to design things that eliminate or at least reduce the number of supports. It does use a lot more material, and it has the potential of interfering with your design. For example, on the water spout, I wanted to make sure no supports ended up inside the water's path. So when I designed the teeth on the piranha plant, I made sure to position them in such a way that the support material wouldn't end up down into the spout. But I did miss something though. Here in the leaf, there is a point that's completely missing. That's because there wasn't enough support material for it, and it resulted in this sort of nest of filament. I'm just glad it didn't ruin the entire print job. So it's something we're gonna roll with and make the best of. One of my favorite parts about taking 3D prints off of the bed is the sound that it makes. It's so satisfying. Now we just need to take the supports off. They come off pretty easily, which is also oddly satisfying.
Now that the supports are all removed, we did a bit of light sanding off camera. There's still this business with that misprint mess. I'm just going to snip it off as much as I can without impacting the rest of the print. With a few files, I'll clean up the sharp edges. To prep for the painting, I'm going to do a once over with some acetone. I find that with a paper towel dampened with acetone, I can rub off the shine on the 3D print. It almost feels a bit like suede, softening up the surface enough to make the acrylic paint stick and absorb a bit better. This piranha plant has a simple color combination of red and green and white. Normally, I would start with the lightest color, then progress to the darker ones, so that any mispaint can easily be covered up with a darker color. But in this case, I decided to start with the red, then green, because I know that I will need quite a few layers to get the color to look solid on this white filament. Each additional coat will add texture and depth to the surface, and I've got a good quality white paint that will cover up dark colors pretty decently with a couple coats. Now with a few dots added on the red body, our Mario-themed piranha plant is ready for showtime.
We had a blast designing and making these spouts, and we hope this inspired you to make a project like this for yourself.
And if you want to 3D print these exact designs or want to use our CAD models as a good starting point, head over to our description and check out the link. Then you can go to the Made in 3D community and download the files for free.
Thanks so much for watching. We'll see you on our next make.